Hi everyone, this is M. Malarvili, working as an assistant professor in the Department of Computer Science and Engineering, Shriram Engineering College, Avinashipalayam, Tirupur. In our college, we are offering higher earning potential, better job opportunities, and strong professional networking for students. And in this video, we are going to see about the insertion of singly linked list. So singly linked list is a linear data structure where elements are stored in individual blocks called nodes. Instead of relying on continuous memory locations like arrays, each node points to the next one via a pointer. That is, each node contains two fields. The first field in the node is used to save the data, and the second field in the node is used to give the address of the next field. And final node points to the null because the last node's next pointer will be null because there is no any other node present after to that. So we are going to see the structure of a node. For defining the structure of the node, we have to create struct node int data and struct node star next. Int data represents the data present in that node, and struct node star next presents the pointer which points to the next node's address. And how can we allocate memory for that node? For that, we have to use malloc function. Malloc is nothing but memory allocation. So we are creating a node called temporary temp, and for that node we are allocating space in the memory system. And in that node we have two fields, data field and the next field. In the data field we have to fill the data called num, and in the next field we have to fill that using the null pointer. So here we are going to insert multiple elements in the list. Suppose we want to create 10 nodes, then this coding will be useful. First node we are creating with a pointer name called head. Head is equal to struct node malloc size of struct node. This is used to create a node with a name head. So we are going to get the data from the user, and we are placing that data in the data field of head node, and the head node's next will be null, and we are placing the head node in the another node name called old. So we are getting the user the number of elements from the user, and using the for loop we are going to create each and every node's memory allocation, and each and every node is filled with its element, and the head tends to next points to the next node of that list, singly linked list. So the next one is insertion at the beginning. The data to be inserted and the position at which the insertion has to be done or got from the user. So in the given one, for empty list, the empty list means we do not have any element in the list. In that case, if head is equal to null, we are going to place that temporary as a head and pointer of that head as null. And if we have any other elements in the list, so we are going to insert at the beginning. The second coding, insert begin, printf enter the element. We are going to get the element from the user, and the element is placed in the temp nodes data place, and the address of the header is placed in the temp nodes next field, and this temp node is now declared as the head node. So the next one is insertion in the middle. Insert mid, p is equal to head. That is, we are allocating another node name called p for head. While p tends to data is not equal to m, that is, m is the element present in that node, we are going to insert a node after that mth element. So while p tends to data is not equal to m, we are going to shift the p to p tends to next. When we reach that target, then the p's next is placed inside the temporary nodes next, and the temp is placed inside the p tends to next. Temp is nothing but the address of the temporary node is placed in the p tends to next p nodes next field. And the final one is insertion at the end. The code for insertion in the end of the list is similar to that of the insertion at the middle. We are also allocating the head node at the node p. While p tends to data is not equal to m, that is the last node's element, we are going to shift the p to p tends to next. Otherwise, we can also use p tends to next is not equal to null. any condition suits for this insertion at the end. When that last node reaches, we have to shift the next pointer of the P to temp tends to next, and the address of the temp to that placed inside the P tends to next. And finally, the uses of singly linked list. A singly linked list is a linear data structure that is primarily used for dynamic memory allocation. This is the primary advantage of singly linked list, where we can allocate the memories dynamically, unlike the array which have continuous memory allocation and fixed memory allocation. And building abstract data structures. We can efficiently build the abstract data structures using a singly linked list. And managing the linear sequential overflow, where forward only traversal is required. As it allocates the memory non-continuously and linked nodes via a single forward pointer, it excels at sequential insertions and deletions without requiring expensive memory shifting. Thank you.